Hi there. In this video, we are going to be looking at object-oriented programming. It is one of the most interesting part of programming in recent years. Now, object-oriented programming basically is a term that is used to describe programming approach based on objects and classes. The object-oriented paradigm allows us to organize software as a collection of objects that consist of both data and behavior. This is in contrast to a conventional functional programming practice that only loosely connects data and behavior. One good thing about object-oriented programming is that it is used to construct a software program into simple, reusable piece of code like blueprints, usually called classes, which are used to create individual instances of objects. Let's take a look at classes and objects in the next few slides. Now, let's take a look at classes and objects in C#. A class is a user-defined blueprint or prototype from which objects are created. It represents the set of properties or methods that are common to all objects of a type. While on the other hand, you have an object. An object is basically an instance of a class. It's created with specific data. Examples of a real-world object could be a dog, a desk, or a television set, or a bicycle. But we're going to be using a vehicle or a car as an example to illustrate our points. A class basically consists of the following: a class keyword, typically written as small letter, and a user-defined class name. So that basically means it could be any name, right? So you start with a keyword and you now give it a name. Then the data or the methods or access modifier are now enclosed within a curly bracket, followed by a semicolon to say that's the end of the class. All right, so what are inside this class? The access specifier. Remember, we've talked about access specifiers or modifier in the last couple of videos. Basically, they could be public, private, or protected. Basically just tells you the access level if it's exposed to other classes in the application or other methods in the application. That's what the access modifier basically represents. Then of course you have the data member. These are variables to be used. Then you talk about the member, or some other application could call them functions. These are the methods to access the data members. They are like the action stuff that takes place in a class. Okay, now let's take a look at this example. A class car. A class car is like a blueprint of other cars, okay? Of these other cars, there's a blueprint. And what does a blueprint contains? It contains the things that do not change. The basic properties or the main properties of the car. For instance, the make, the model, the color, the year, or the price. So they must have all these things. So these are the things that will be here. But the object is an instance. It takes all the property defines here and it now gives it its own unique color, for instance. So there's a color there, but the object, when it's created, will not say, now I want my color to be green, or I want my color to be blue or red. So that is just how that works. Now, of course, the methods, which is key again. The methods, these are like action words. For instance, the car can start. You can drive the car. You can park the car. So these are action words and they are declared as well. Then, of course, we have what we call the events. The events are basically things that happens, okay? On start, what happens? Or on park, what happens? Or on break, what happens? These are events, that a user can define as well. All right? So that's basically the anatomy of a class and an object, right? There's no way we can talk about object-oriented programming without talking about the 4 pillars. That is, the 4 key techniques used in OOP. Number 1 is abstraction. Abstraction only exposes high-level public methods for assessing an object. That basically means that a group of related properties, methods, and other members are treated as a single unit of an object. Then the second one is encapsulation. Encapsulation contains information in an object, exposing only selected information. This means hiding the unnecessary details. Then the third one is inheritance. Inheritance is like a child class inherits data and behaviors from parent class. Inheritance allows classes to inherit features of other classes. Put another way, parent classes extends attributes and behaviors to child classes. Inheritance supports reusability. That is one major advantage that it has. So it basically describes the ability to create new classes based on an existing class. Then the last one there is the polymorphism. Polymorphism basically means many methods can do the same task. It means that you can have multiple classes that can be used interchangeably, even though each class implements the same properties or method in different ways.